We are going through the topic of volume studies, and as part of the outcome related to traffic data collection and analysis, we have looked at the different terms, the variation volume, the intersection counts, which can be sometimes the arrival and sometimes for the departure. And we have discussed the conditions for them, the representation of intersection volumes, how it is done intentionally and how it is done in Bahrain. Then we moved on to network studies, and network studies can be of two types. We have limited network, which is done for a specific facility, for a specific purpose, and then we have the statewide, which is done for the state level, okay, by the country, by the government, okay, to manage the roads. But right now we are talking about the details of the limited network study, and the most important thing is any network study needs some sampling. You cannot collect data entirely of the whole network. So we discussed how the samples are made. So we select, first of all, we divide our network into subgroups, and each subgroup has same type of area and same type of highways. Okay, and then within each subgroup we assign some points as control, some points as coverage. Okay, and the control should be full count and the coverage is partial count. Okay, today we will start with one of the examples of how we can use the control count to calculate the full count of the coverage. Okay, now remember what we have, or you can look at the example. Let us move directly to this example. I have total 7 segments in my small network. Okay, so it's a small network subgroup. Okay, because all of them are together. Okay, so if it's not a subgroup, then all points cannot be considered together. Okay, so if this point is on a arterial and this point is on a collector, they cannot be in the same subgroup. Okay, so because they are in the same subgroup and we will process them together, it means they are same. Okay, clear?
What are these points?
Segments on which I will collect data.
So it's a highway like this.
Highway segments. Okay. No highway goes like this. What is this? Everybody done with it? Huh?
Barcelona have roads like this.
Okay. When you will take me there, I will see.
I saw it from
Mughal. You don't have to do everything now. Inshallah, you have life left after the classes. Okay.
like this.
It's not one highway.
Intersections.
Okay. So it's one subgroup. Okay. So all points are of the same type. Basically, the point is all these segments are of the same type. There are 7 of them. One of them is control. Okay. And the other ones are coverage. Which one is control? They have coded it as A. The others are coded with numbers. Okay. So the one which are coded with numbers, they are coverage. The one which is coded as A is the control. Okay. On control, we take the full count. Okay. What do we mean by full count? The one which is required. In this study, they need count of these 8 hours. So control, this point has a count of these full 8 hours.
So it's depend on the questions.
It depends on the question. Depends upon the client. Okay. Clear? On the remaining points, 8 hours data is not taken. That's why we are calling them coverage. Got it? If I took 8 hours of data in any other point, that will become control. So you need to keep the difference in mind. Okay? Control is full, coverage is some part of it. If it is full, then it is control. Okay? If it is less than full, it is coverage. Okay? Now, here they have a restriction of number of teams. Or maybe they are using sensors, detectors for collecting data. Whatever they are using, they have only 2. Okay, so at a time they can do 2 points. Okay, at a time they can do 2 points, and one of those points has to be A. Okay, because I need the full count here, so I cannot remove the counter from here. In the 8 hours, the counter will remain here.
So they only have
One left now. Okay, they have one team or one counter left for the remaining 6 points. Okay? Okay, now keep another rule in mind. The counting period between control and coverage must overlap. There must be an overlapping between the control and the coverage counting periods. Okay, so I cannot do 8 hours on point A today and point 1 tomorrow. It cannot happen. Okay, this is what I mean by overlap. They must be happening at the same time. Got it? Okay, they must be happening at the same time. So how are they doing it now in this question? This table gives you an idea. So on a particular day, they are calling it a typical weekday. Okay, Monday, Tuesday, Wednesday, typical weekday. So on any of the typical weekday, they collected 8 hours of data on location A. And here you see the count of 8 hours for location A. Clear? Okay, it's full 8 hours because control point. Clear? Okay. On the same day, they are also collecting data on other locations for the same 8 hours. Remember I told you there must be overlap, right? Okay. Now how many teams I had? 2. Okay. So one here, the other will go from each location to the other location. Okay. They must overlap, but they are not completely same, because if they are same, then all of them are controlled. Okay. They are overlapping, but they are not all 8 hours. Okay. So how many hours are there? Location 1. How many hours? 1 hour. Okay. Next hour they go to location 2. Okay. Clear or not? Okay. So for the control I have the 8 hours of data. For the other locations I have how many hours of data? Each location how many hours of data? 1 hour. Okay. But my requirement is, sorry?
Moving time from location to location.
Yes, I don't know where it went. I don't know. It's in the book like this. Okay. So going back to the point here, how many hours of data I need? I need 8 hours of data, right? So location A, I need 8 hours. I have 8 hours. Done. Okay, no problem with location A. Location, other locations, I need 8 hours of data, and I have only 1 hour of data. Okay, so somehow I need to convert this 1 hour into 8 hours. Clear? Okay. Whatever conversion we will do, the factors will come from my control count. Okay, please keep this in mind as well. We will do multiple variations of the same problem. Whatever conversion I will do with the other counts, the factors of conversion will always come from control. Got it? Okay. So first of all, I will go to the control count, which is location A, and I will calculate its total. Give me the total for location A.
Seven zero six seven.
7067. Okay, these are the number of vehicles which we have on location A in full 8 hours. Okay. Now for other locations, the data is 1 hour. I want to expand it to 8 hours, right? So the factors which I need are called as expansion factors. So for each hour of these 8 hours, I will calculate a conversion factor which is called as expansion factors. So I have the hours here, and I have the expansion factor here. The first hour is 12 to 1. Okay, how will we calculate the expansion factor? I'll take the ratio of the traffic of that hour divided by 2. Okay, so the expansion factor for 12 to 1 is this, which is basically what? The percentage, right? How much percentage of total is coming in this 1 hour?
11.7. 11.7.
1117, right? They don't multiply with 100, so just keeping it as it is. Okay, but you know the ratio is, you are dividing the 1 hour with the total, so it gives you the proportion of traffic in that 1 hour. Clear or not? Any questions? Okay, same will happen for the remaining hours. Okay, what are the factors?
0.115,
You will take the values from here and divide by the total. Yes.
0.115, 0.129, 0.137,
What?
0.149, 0.163, 0.133, 0.056,
5?
0.056.
Okay. Now I have the expansion factor. I will go to each location now, the remaining. I want to convert them, right? The control count is done. Okay, so I'm more now targeting the other locations. Okay, so I will see which hour matches which location. So hour 12 to 1 matches which location? Location 1, right? Okay, so this factor will be used for location 1. Hour 1 to 2 matches location 2. Okay, hour 2 to 3 matches location 3. Hour 3 to 4 matches with location? Huh? Hour 3 to 4
Will be interpolation.
matches with location. My question is there a location matching hour 3 to 4? No. Or just leave it, as you leave many things in your life. Okay? Don't go after it. Where is the location for 3 to 4? Just leave it. Okay? So 4 to 5, which location? 4. Okay? 5 to 6? 6 to 7? 6. 7 to 8? Nothing. Clear or not? Okay? So overlapping is necessary. But it's not necessary, they will find each and every hour somewhere. Okay, there is an overlap, yes. Okay, but overlap is not complete. Any part of overlapping is fine. Okay, some hours are not overlapping, they are missing, done, fine. Khalas, okay, we move forward. Okay, now for each location, I will calculate the 8-hour count. Okay, so as I mentioned, this is like a proportion, right? This is like a proportion. So I will use this proportion to calculate the total now. This is the the traffic in this hour, right? Okay, and this hour has how much proportion? This much. Okay, so you have the part and you have the proportion. Now you need the total. Okay, so we will divide. Okay, this will give you total 8 hours.
7179.
Okay, for this one, you will take the traffic from here and you look in the proportion which is for this hour. How much is this?
543435.
Yes, next one. Any questions?
Why did you divide?
Uh-huh.
Why did we divide?
What else you want to do? What else you want to do? Multiply? Multiply?
We'll get a small number.
Yes.
But
So-
why do we divide?
Why do we divide?
Because we can't collect
Huh? You have the part, you want the total, so you divide. If you have the total, you want the part, you multiply. Huh? Just saying okay or you got it?
Okay.
If I give you total of something and ask you for a part, what you will do? Multiply by the factor. Now I'm giving you the part. This is the part. And I'm asking for the total. So you will divide. Yes, next one.
1651.
1651
4651.
465.
Two eight five seven. No.
No?
2617.
Okay, next. Hmm? 7458. 53. Next.
9135.
Yes, anyone has any questions? All clear, right?
No, no.
Mm-hmm. Get up.
No, when you say okay, I say yes. You
Huh?
tell me you're lying. I wouldn't lie to you.
All clear, right?
Okay.
All clear, yes. You don't have any questions because you don't know what is happening. Can you ask me a question? You don't? You can't? Anybody has any questions? Yes? Sorry? Yes. Point was 1440 divided by what? 0.133, yes. 10827. What are you guys doing? Anyways, anybody has any questions? Okay. Now we have found the 8-hour count, so the counting is complete. Okay, the final values which they wanted are all here. Okay. Now let's say look at the counts which are done at the control again, because control has a full 8 hours. Okay. Now tell me from the control point which one is the peak hour. 6 to 7, right? This is the peak hour. Okay.
5 to 6.
5 to 6? 5 to 6. Okay. 5 to 6 is the peak hour. It gives you an idea that I don't care whatever you are saying. If you give me wrong values, I will say, okay, fine. Okay, so you have to pay attention. So 5 to 6 is the peak hour. Now, the logic behind all this calculation is that control and coverage, all locations, belong to the same type of network. They are the same type of highway, the same type of area. So if I identify any trend on control, it remains the same on the other locations as well. Okay. For example, you identified peak hour on the control, right? Which was 5 to 6. Okay. So the logic says that other points should have the same peak hour. Got it? Okay. If the peak hour on the control count location is 5 to 6, the other locations will have peak traffic in the same hour. I'm not saying the traffic will be same. I'm saying the hour will be same. Okay? Clear or not? Okay. So for example, you go to a commercial area, okay, diplomatic area, for example. They have the peak hour maybe from 8 to something. Okay. Whether you take it at one road of that area or the next street of that area. Is it possible? Okay, this street is full, the other one is empty, nothing. No, it's the same pattern, right? It will repeat. Okay. So this is a logical conclusion that yes, if the peak hour at control count is between 6 to 7, then the peak hour at the other locations will also be in the same time period. Got it? Okay. So we know the peak hour at all these locations is between 5 to 6. Okay. We know that timing is 5 to 6. But what is the value of this timing? Okay. How much value of traffic I have in this hour on all locations? For control location, I know 5 to 6 peak hour traffic is this much. We observed it. Okay. Now look at the other locations. 5 to 6. What is the value?
1215.
Huh?
1215.
Where is it?
The table.
Which location? Location 5. Okay, so location 5, no problem. The hour was 5 to 6. Peak hour was 5 to 6. The data is taken 5 to 6, no problem. Can I say the same will happen on the other locations? No. Okay, the value cannot be same. The hour is. The value cannot be same. Okay, so now I want the value now. Okay, I want value of hour 5 to 6 on other locations. Okay, on other locations. So for example, if I take location 1, so I'm looking for peak hour volume. Location 1, the total is 7179. Total of 8 hours. Out of total of 8 hours, hour 5 to 6 has how much traffic? Okay. So now I have the total, I want the part. I want the part, right? So now I will do what? Multiply. I don't know, maybe. Huh? Say again. The higher is highest. Yeah, it should be obviously. Because it's a ratio, right? Hmm? Okay, so how much is this? 1170. Okay. For the second location, I'll pick this. Okay. This is my total, right? For the second location. Multiply with what factor? Same, because I need the same hour, right? Okay, so peak hour is same, the time is same. So I will take the same factor and I will keep on multiplying with the totals. Clear? Clear? Any questions? Okay, so this will continue for the remaining locations. Any problems?
Lecture.
Then what?
The peak hour is the highest expansion factor.
It should be, yes. It should be. Any other question? Okay. This is what I don't know. Okay, moving on. It's the same network. Same network. Okay. 7 locations. One of them is control. The other 6 are coverage. But now we are changing the study period. Okay. In the previous example, the study period was 8 hours of 1 day. Okay, 8 hours of 1 day. Now the study period is multiple days. Okay, so the coverage will not be 1 day value. Coverage is multiple days values. Okay, but the rules will remain the same. There must be some overlapping between the count and the coverage. And whatever trend you see on the control, the same trend will be on the coverage as well. Okay, these two rules will remain the same, whatever you are doing. Okay, so you can see multiple days of data on location A. Okay, and this is the data for each day. There. Now for the remaining, I have location 1, this data. Okay, no other day on location 1. Okay, location 2, this day, no other data on location 2. Got it? Clear? Okay. Now for location, whenever we have multiple days of data, usually we take the average. Okay, more than 1 day of data, we take the daily average. Okay, we take the daily average.
Why, doctor?
Why?
Because
You studied in volume. Volume can be what? Daily and hour. Okay, so these are the usual units we take. Yes, you can have 7 days, 6 days total volume, no problem. But this is not usually taken in the analysis. The analysis is usually based on daily volumes and hourly volumes. Okay, we have used them earlier, and in the next topics you will see them. That we do not use total volume of multiple days. Okay, 7 days volume, and now I will do this with it. No. Okay, so whenever you have multiple days of data, we take the daily average. Okay, so here I will take the daily average. Got it? Okay, so what is the daily average for location A? It's simple average. How much?
Multiply by 3.
Daily average. What multiply? You just take the numbers and do the average. That's it.
seven, three,
7, 3, 5,
five. Consummation and I divided by
5 0.
5, 0.
5 0.
This is the average of 6 days. You can count them here. We have the average of 6 days. All of these days are what? All of these days are what? Weekdays. Okay? All of these are weekdays. Not for us, but for them. Okay? So, now, we had multiple days of data. I calculated an average. Okay? I can do that for control. But for coverage, I cannot do that. Okay? So, again, I have to use some conversion factors to calculate the average for the other locations. The same thing which I did in the previous example. But there, it was hour and converted to 8 hours. So I was using expansion factor. Here it is 1 day. Every location has 1 day, right? Yes. And I want to convert it to average. So I will not use the same conversion factor. And the conversion factor which we will use is called the adjustment factor. Okay, so now I need the adjustment factors now. So each day will have an adjustment factor now.
It's called AF.
Hmm. So Monday 1, because I have 2 Mondays. So okay, so for Monday 1, how do we calculate the adjustment factor? You take the count of that day from the control. I told you in the previous example, all factors come from control. Whatever conversion factor you want, it will come from control. Okay, so I will take the count of that day from control, divide by the average of the control. So 7,000 divided by 7350. How much is that?
0.952.
Okay, the same for the other days. The average will remain the same. You will take the values from the control. Okay, how much?
1.047.
1.0. Okay, next.
1.54. 0.95. 0.8.
Hmm?
0.857.
Okay, pay attention now. There is a check which you can apply to these factors. Okay, for the expansion factors, these are ratios, right? So their total should be 1. Okay, once you calculate them, you check. These, there is no check on the total, but there is a check that some of them should be less than 1 and some of them should be more than 1, because you are taking the ratio with the average, right? So average is supposed to be in the middle. So some values will be more than that and some values will be less than that. So if you are getting all the values of the factors more than 1, you have a problem. If you are getting all the values less than 1, you have a problem. Okay, they should be a mix. Got it? Okay, so keep this in mind. Now how to apply the expansion factor? Again, I will match with the location. Okay, the day with the location. Okay, Monday 1, location is 1. Okay, Tuesday location is 2. Okay, they are going in sequence, so there is no problem here. There are no missing days here, but there could be, and it's not wrong. If I had 5 locations, I'll not do the survey for an extra day. Okay, here I have 6 locations and 6 days. That's why. Okay, now I need the average for the other locations. So I'll take the count and I will multiply. I'll multiply with the adjustment factor I have. Okay, so 6, 5.
Didn't divide it.
Sorry,
Why we didn't divide?
why we didn't divide it? How did we calculate the adjustment factor? You are calculating it like this, right? The day count divided by the average. Now you need the average. Okay? You need the average, right? So you will flip. You're using the same equation. Yes?
So for the previous question, all of the factors should be equal to 1, right?
Yes.
This is how you make sure that your factors are right.
Yes.
Here, can you check?
No.
You can. By taking
All
the
factors should be equal to what?
the average of all factors should equal to 1.
Average of all factors. Good. Very good. Well done. Okay. Moving on. How much is this?
6175.
Okay. So in the next one, you will take this one and multiply with the factor of the location.
6510.
6,
510.
okay, and continue. Okay, you will go check each location, which day is it, multiply with the factor of that location. Clear? Any questions? Okay. Another variation of the same example, same network. Okay, 1 control, 6 coverage. Okay, but here this complete data is for control. The complete data is for control. Tell me how many days the data is taken?
3.
3 days, right? 3 days. And the data is divided into how many hours?
8.
No. One interval, how many hours?
4.
4 hours. Okay? Clear or not? Okay. So for the control, there is no problem. If I have multiple days of data, what do we do with it? We take average. Any problem taking average here? No problem, right? 3 days of data. For every day there is a value. Take an average. Clear? Okay. What's the average?
Six, 9, 6, 6, 6, 7.
6, 9, 6, 7. This is average of 3 days on location A. Okay, no problem. Up till now, I only showed you the data for location A. Now I'll show you the data for other locations. Okay, so if I go to any one location, how many hours of data I have? At one location, how many hours of data? 4 hours of data. Okay, for the control, I had total how many hours of data? Total for one day. 8. Okay, so first thing I need to do is convert this 4 hours into 8 hours. Without this, there is no average, right? I cannot do the average. Got it? Okay. This is similar to the example number 1. You had 1 hour of data and you were converting it to 8 hours, right? Here, the number of hours have changed. The problem is still the same. You have 4 hours of data, convert it to 8 hours. Okay. So we'll use the same approach. We will take the ratio, okay, 4 hours upon total, and you will get a factor. What do we call that factor? Huh? No. Expansion factor. Okay. Now they already did it. Okay. So these are the expansion factors for each 4 hour period. Okay. There is the expansion factor for this 4 hours, expansion factor for these 4 hours. How did I get it? This value divided by total. This is the answer. How did I get this one? This value divided by total. This is the answer. Got it?
Yes.
Okay.
Lecture, when can I use adjustment factor and then the other factor?
Adjustment factor is when you have a value and you need the average. And expansion factor is when you have some hours of data but you want the full count. Then you will use the adjustment factor. Okay. Okay, so station, location, whatever, 1. Okay, the data is 2213. This is Monday 12 to 4. My expansion factor is 0.429. So what do we do? Multiply or divide? Divide. Okay, this will give me full 8 hours. Location 1. How much is that? 5159. Okay, these are now 8 hour counts. Okay, next one. 3,428. Factor is 0.571.
Point two, point four.
5. Okay, next one.
Six two, five seven. Four three, 63.
Okay, in each case, I am taking the value from here, looking at the day and the hour, and taking the factor from here.
6108. Doctor,
5751.
This one, which one?
Last one.
5, 7, 5,
2.
2.
Uh-huh.
2,500 divided by 0.438. Right?
560.
Tuesday and Wednesday, I think.
Your last one 6673.
Who gave me last one?
I don't know.
Okay. Now, these are 1 days of value. Okay. For the control, I had an average, right? For the control, I have calculated an average because there were 3 days of values. Okay. So I must calculate an average for the other locations as well. Okay. You cannot leave it for 1 day. Okay. So for now, it goes to the same stage as example number 2. Example number 2 was the same. You had 1 day of data and you wanted the average, right? Okay, so you did the first step. Now you have 1 day of data at every location, but you need an average. Okay, so I will use which factor now? Expansion factor we already used. Now I'll use the adjustment factor.
If your number 5 wrong.
Obviously it's wrong. Number 3 is also wrong. Very good. Okay, so the adjustment factor was, you take the value of that day, divide by the average, right? These days are wrong, sorry. We have only 3 days, right? So Monday, Tuesday, Wednesday, right? And the locations are also not the same. Okay, sorry for that. So we have location 1, okay, location 1 and 2 on Monday, right? Location 2 and 3, 3 and 4 on Tuesday. And then we have the remaining 2 on Wednesday. Okay, so we will use the same adjustment factor. The day remains the same, the adjustment factor remains the same. So for Monday, but all factors come from control, as I already mentioned. Their calculation is from control. Okay. So I'll take the value of Monday, divide by the average. How much do I get?
1. You want what? It's approximately 1.
Approximately 1.
1.004.
Okay, for Tuesday, you will take this value, divide by that. How much? How much?
Which value?
Tuesday value.
Oh, it's for both. Divided by 6967. 1.08.
Wednesday, how much?
Actually, Wednesday, the 8 hour it's wrong.
Huh?
8 hour value it's wrong.
Yes, yes, but first give me this factor. How much? 6,400.
0.92.
Okay. What is this?
Number 4 will be 7991.
Okay. So now we have the adjustment factor. Okay, I have the total of the day and I have the adjustment factor. I will multiply them. I will get the average for that location. Obviously, first two locations, no problem, because I have the factor as 1.
Mr. Why is 1?
Hmm?
Why is 1?
Why is
Okay,
1?
1.004.
So, it's maths. Anything can come. Sometimes I put your grades in the Excel sheet, F comes. Anything can happen. It's maths. There is no Y here. Okay, this one, so you multiply now. Okay, you take this value, multiply the factor. Okay, remember, I already matched the day from here. Okay, so you have to do this first before you start multiplying and dividing. Make a table where you are matching the location with the days and the hours. Sorry, the average is 5254. And you found it using the calculator.
675.
675. Okay, and the rest. Got it? Clear, everybody?
8 hour multiplied by AF.
Yes. Clear? Any questions? Okay. This is the bigger network. Thankfully, we have like extended sessions, so I can do like these are same examples. So yes.
So, does the control have to be in the middle?
What do you mean?
Control is in the middle.
Yeah, if it can be, yes, it's better. It's not a requirement. If it can be managed, then yes. If not, fine, no problem. Okay, this is the bigger network now, but again, it should be a subgroup because I will use these points together. That means all these points are same type of highway, same type of area. Okay, so this subgroup has 10 segments now. One of them is control, the other 9 are coverage. Again, we have the same poor contractor which has only 2 teams, okay, or 2 sets of data collectors. So you can do 2 at a time, okay, and 2 at a time means one will be where?
A.
Okay, because we need the full. Okay, so this is what he did. Now he was using pneumatic road tubes. Okay, there are tubes on the road. We discussed in lecture number 2, and they are counting number of axles, not number of vehicles, but number of wheels basically. How many times the wheels are crossing? Got it? So you have the axle count here, and you can look at the counts how they are taken. The first table for the control, the second one for the coverage. Okay, now you are asking the time for shifting, right? Okay,
Yes,
the time for shifting is there now. You see a 15 minutes break,
We extend the time for 1 hour.
4 hours. Okay, but the 15 minutes break could be for shifting the tube from one location to the other location. So you finish here at 11:45, you will start with the next location at 12.
But it should counted already.
Huh?
But it should counted.
We cannot do it, right?
Yeah.
Otherwise you will miss the, how will you shift? Okay, so that's why we have a break. Okay. We keep it well, obviously. Okay. So now you see the overlapping here. The count is taken on the same days during the same time. Okay, you see the overlapping here of the time period. Where am I doing shifting? I'm doing shifting here. Control is not supposed to be shifted. Control does not need any shifting. If it was manual, it will make sense. Okay, there's somebody counting, he needs to take a break. Even on a control point, he needs to take a break, he or she. Okay, but in this case, if they are saying it's pneumatic road tubes, shifting is not required there, but we are doing it for the sake of overlapping. Okay, you saw in the first example, the coverage had 1 hour counts, right? Control also had 1 hour counts. Second example, the coverage had 1 day count. The control also had 1 day, multiple days, but each count was full day. Okay. Third example, the coverage had 4 hour counts. Control also had 4 hour intervals. Okay. So the intervals need overlapping as well. Okay. Now, first thing we will do is what we have already done in lecture number 2, which is to fill out the break. Okay. Now, what type of break we are using? There are 2 types of breaks: alternative breaks and breaks within the counting period. Which type is this? This is within the counting period. There is no alternate here, right? Otherwise, you will see 4 hours of counting, 4 hours of break. That will be happens, right? Not so here. So we have to fill out the break. Okay. So what do we do to fill out this break? Tell me.
We use Vx or V1. We can't have
Yes. I wrote this equation. I don't know why. I wrote it myself. I don't remember what you are saying. So tell me in simple words.
Calculate the amount of minutes
Yes.
and the ratio.
Yes. The ratio. Okay. So for example, 3000. Okay. It's taken in 3 hours 45 minutes, right? Okay. So you can do something like this. This will give you count per minute. Okay. And then you need it for 4 hours, right?
Yes.
Okay. Clear or not? No. Clear now? So if you ask some question in the exam, I'll go and turn on the light. It should be clear. Anybody have any question? Okay. This should be done for which values? This? Is it for a particular point or for all the values? All, right? This will apply to all the values. Okay? Once you do it for all the values will become 4 hours. Okay? And now, going back to the control now. I'm going back to the control. So imagine control count has 4 hour values for, like it has complete 4 hour values now. Okay? The control has complete 4 hour values. How many days of data we have? 3 days of data, right? If we have multiple days, what do? We take average. Okay. So after you do this, you go back to the control count and you calculate the average of 3 days. Okay. So you take the total of each day and you will calculate the average. Okay. I may have done it somewhere here. It's not there. Anyways, it's there. This one. So this is the average of the 3 days for the control. So first thing is convert all these values to 4 hours, then take the total of each day, okay, and then you do the average of these 3 values. Clear? Okay? You will do the same thing for these points, right? Now tell me, for each point, how many hours of data I will have? For each point, after I do this here. For each point, how many hours of data I will get? 4 hours, right? Okay. Control. Go back to the control. For each day, how many hours of data control has? No. For each day. 12, right? Okay. But the coverage has 4 hours. So first thing is to do what? Control coverage to, convert 4 hours to 12 hours. Which factors? Expansion factor. Okay. How do we calculate the expansion factor?
Summation the total and divided by the average number.
Yeah. Total, average, everything into one, right? How do we calculate the expansion factor? Count over the total. Okay. So you take the value of 4 hours from here after conversion, and you will divide by the total of this day. Okay. Total of that day. Clear? You did this, you got 4 hours. I need the expansion factor of these 4 hours. Okay? So I will take the total of the day. This divide by the total. Will give you the expansion factor.
For each 3000 axle or vehicle?
These are axles.
All the data.
All the data is axles. Okay? So then you will take, like we did in the first example, in the third example, you will take expansion factor for each 4 hour period and divide these numbers with the expansion factors. The 4 hour numbers, not these, the 4 hour numbers. Okay? So the 4 hours will be converted to 12 hours. Okay? Then the next step is you have the average of 3 days for the control. Till now you have calculated 1 day value for each count. So I need to convert it into average. Okay. So like we did, it's the same as this one. For every day you will calculate an adjustment factor. Okay. So you will need the average of 3 days for the control, and you will use the total upon the average to calculate the adjustment factor for that day. Okay. Then you will go and match the day with the station. Okay, so the 8 hour value, the 12 hour value, 1 day value of this will be multiplied with the adjustment factor of Monday. Okay, the 12 hour value of this location again multiply with the adjustment factor of Monday, and so on and so forth. The procedure is given here. Okay, with the extra step of converting the axles to the number of vehicles, and we have done it in lecture number 2. Okay, we are using pneumatic road tubes which do not count number of vehicles, they count only number of axles. Okay, you can do it first or you can do it at the end, whatever suits you. At the end is better because you will have only one value for each location. So for example, they did the manual count on that location. The purpose of the manual count is to know axles per vehicle, average number of axles per vehicle. Okay, so I need total number of axles and total number of vehicles. How many vehicles I have total here?
Um, 1276.
Okay, then I need number of axles. Number of axles, just to refresh your mind, you will take the vehicle count, multiply with the number of axles here. I need the total. Okay, I need the total. So 2 axles, how many times?
2.
This many times. 3 axles, how many times? This many times. You have to multiply. Okay, 2780. Okay, so 2 into this, plus 3 into this, plus 4 into this, and so on.
2.18.
Now you will divide. Okay, so 2780 divided by 1276, how much?
2.18.
2.18. Okay, if you get this value less than 2, you have a problem. This value less than 2, we'll have a problem.
Motorcycle.
Huh? Motorcycle is one meeting. Then yes. Motorcycles are still 2 counts.
Unicycle.
No, we
Unicycle.
have scooter, have one.
Huh?
We have one type of scooter, have one. One piece.
Okay. Now, once you get the 12-hour count, 12-hour Excel count, okay, so I have the 12-hour Excel count for control point, which is 11,804. To convert it to number of vehicles, I divide by this number, 2.18.
One Excel.
Huh?
One Excel is
कितला है कितला unicycle maybe he's rusty with it.
Okay. Any problem? Okay. So this is up to you. The procedure is written here, complete. What you have to do step by step. You go step by step. And if you have any problems, you can show me later on. But you never have problems because you never do it. So I'm relaxed. Okay. Another important thing about network volumes is the vehicle miles traveled. Okay. A term which is called as vehicle miles traveled. If you change the units, it can be called as vehicle kilometers traveled. Okay, but means the same thing. Vehicle miles traveled or vehicle kilometers traveled are said to be the indicator of importance of the highway. Okay, highway importance is because of 2 reasons. One is how many people are using it, and the other is how long is it. Okay, the highway is long, that means connecting more areas, right? Or it is taking you to a place which is further. Okay, so they combine both of them, and they are calling it vehicle miles traveled or vehicle kilometers traveled. So vehicle is number of vehicles. Okay, and mile is length of the highway. You multiply them. Okay, this is how you get vehicle miles traveled or vehicle kilometers traveled. Got it? Take the number of vehicles, multiply with the length. Got it? If the number is higher, importance is higher. Okay, because one reason or the other. Clear? So if you have the count and you have the length, you multiply them, you get vehicle miles traveled. Okay? The highway maintenance strategies, the highway operation, highway management, it all depends upon vehicle miles traveled. Okay? It also gives you the idea about the travel which is done in that area. Okay? So how many the frequency of travel or the intensity of travel. Okay, the intensity of travel is measured in vehicle miles traveled. Okay, how frequently and how more people are on the roads. Okay, so this is also measured by vehicle miles traveled. Okay, so it's a more comprehensive indicator of travel rather than volume. Volume is one indicator, yes. Okay, but a more comprehensive indicator of travel pattern or travel usage is, or highway usage is vehicle miles traveled. Okay, now as you can see here, they did it for each segment separate and then they added it. So this is for this segment, segment A. This one is for segment 1 and so on and so forth. If you add them together, then it becomes for the entire network. Okay, so vehicle miles traveled can be for the entire network. Okay, clear or not? Another thing is, when you are counting, you count for a specific time, right? Here in this case, the count is 8 hours. So vehicle miles traveled are also for 8 hours. Okay, so you have to go back and check the timing of the count and the length. This will tell you this number applies to how much of the area and how much of the time. Okay, so I cannot say this is the vehicle miles traveled for the whole year. This is 8 hours.
Because it's always 8 hours.
No. This is what I am saying. It will change to 12 hours, so the vehicle miles traveled will become for 12 hours. Okay, so there is no constant number here. Okay, this is what we call as a network flow map. It's a representation of network volumes. How do we represent network volumes? You can see the actual numbers written here. Okay, these numbers are the volumes for these segments. Okay, clear? Another thing which we do is scaling the width of the road according to these numbers. Okay, so the width of the road is a representation of this number. If number increases, you can see now. This one is 7,100, 7,300. Number increase, right? The width also.
It's like the arrow example.
Yes. Clear or not? Okay. Then, now remember I told you we have two types of network studies. One is called as a limited network, which we just finished. Okay. Then we have the statewide counting program, the statewide network study. Statewide meaning that it's for the whole state, for the whole country. Okay. Or for one province or one area or whatever, if the country is big enough. Okay. So statewide means that the government is doing it for managing the roads. For limited network, we have a client who comes up. I told you it's done for new developments. A client comes and he says, okay, I'm going to build a new development here. Okay, if the development is big enough, the government will tell him, you do a traffic impact study. For that traffic impact study, he will do the counting study of the network. Okay, that is limited network study. But the government itself is doing their own network study continuously. Okay, so this one is a continuous program. Statewide is a continuous program. Okay, and it needs to be done for all the roads which are ideally for all the roads which are in the kingdom or in the state or in the country. Okay. Sorry. So it's green, right? Okay. Now, a statewide counting program is done to mainly focus on three things. What is the average yearly traffic, AADT? Okay, the average daily traffic of the year. How the traffic is shifting within the year. Okay, every month, weekdays, weekends, how the traffic is shifting. And the last thing which I already told you, vehicle miles traveled. Vehicle miles traveled will give indication to the authorities which highways and which areas are more important and which ones are less. Okay. Before starting this program, the government must assign the highways their types. This highway of this type, this highway of this type, this highway of this type. Because I told you, you need to make subgroups. So until you fix the types, you cannot make the subgroups. Okay. And again, the same rule applies here. Each subgroup should be of the same type of highway, same type of area. Okay. The first thing you do is you assign the types, you find out what type of areas you have, and you divide them into subgroups. Each subgroup will have some control counts and some coverage counts. Okay. Same as the limited network. Okay. Yeah. The main difference between the limited network study and the statewide program is the area. The area is big now. It's not a small network now, around one building, around one development. It's the whole country, basically. Okay? And the time. We saw the examples, 8 hour, 12 hour, 6 days, 3 days. This is year wide, year long. Okay, the whole year, continuous. This is a continuous program. Okay, so we have some guidelines for establishing the control in the coverage locations. Every segment, which is 2 miles, after every 2 mile segment, there should be a counting location. Okay, there should not be any 2 mile interval on the highways, which is without counting, except for streets which are very rarely used. Okay, so the traffic volume on them is very low. For example, they are giving us an indication here. If the average of the whole day, remember this is whole day. Okay, some of you have done the counts for 15 minutes. Okay, and you got like values in hundreds, right? Okay, so imagine a street which has less than 1,000 vehicles in the whole day. Okay, so this will be out of this statewide program, you may still go and count that street for some special purpose. Okay, but this regular management program will not count this one. Okay. We had the ratio of control to coverage. In this case, the ratio of control to coverage is larger because my network is bigger. It's larger. Okay. So with one control, you can cover up to 50 coverage locations. In a subgroup of highways, if you have one control, you can go up to 50 coverage locations. Okay. Yeah. In the statewide program, we didn't have the type of control. All control was control. Okay. In the statewide program, we have 3 different types of control points. We have permanent, we have major, we have minor. Permanent means there's a sensor, it covers the data for the whole year. Major means we have a sensor which is installed and then taken. So it's not continuous. It's not for 365 days. Every month we do it for 1 week. Okay. Major control count is done for 1 week every month. Okay. Minor is done for even for a longer interval. Okay, which is they are saying 5 days every season. 5 days every season. Season doesn't mean you come and see the temperature, season has changed or not. Okay, meaning 3-4 times a year. Okay, so minor control is usually 5 days every 3-4 times a year. Okay, after every 3-4 months. Anything which is less than that is considered as coverage. Anything which is even less than 5 days for 3 times or 4 times a year is considered as coverage. Some of the locations for main highways, you can have a look at it later on. Yeah.